family a very happy and healthy life ahead, kindly request you to take necessary precautions for your own safety to overcome with this phase as well. We at Global Knowledge Research Foundation are thankful to our all guests for being a part of this virtual conference for making it successfully as the previous ones. Hope you will enjoy the day of interactive session. I would want to let the presenter know that they will be given 8 minutes for their entire presentation and 2 minutes for any queries. I humbly request to stick to the allotted time. Now I would like to introduce our session chair, Dr. Anubha Jain. She is an associate professor and head Department of Computer Science and IT, the IS University, Jaipur, India. She has 20 years of teaching experience. Her research or her area of interest is software engineering, algorithms, data structure, programming language, information retrieval, information architecture, e-banking, and secure transaction and web applications. Welcome, ma'am. Dear ma'am, I welcome you. And now I would want you to take this session and continue further.
Thank you, Richa. Thank you very much. Namaskar, everybody. I firstly thank all the organizers for organizing such a wonderful conference and congratulate them for the 6th version of this conference. And thank you once again for inviting me as a session chair. To all the participants, I wish all the best. You should all have a good presentation, and I hope that this conference will help you in taking back good suggestions for further research. So all the best, and let's start with the session.
Yes. So now I call our first presenter, Dipesh Vanwani. I think Dipesh Vanwani is absent. So now I call our next presenter, Smitha. Smita, I'm unmuting you. Please go ahead with your presentation. Hello. Hello.
Yeah, Richa.
Smita has some problem. Hello. Okay, we can. I think Smita has some internet problem. We can call our next presenter, Amir Pule. Amir Pule, is it there?
Amit Phule is not there.
I can call up our next presenter. It's Sambhavi.
Sambhavi is there.
Yeah. Hello.
Yes,
Can you hear
Sambhavi.
me?
Yes, Sambhavi. Please start the presentation.
Yeah, sure. Just a second. Yeah, is it visible? I'm sharing the screen.
Yeah, it is visible.
Yeah, okay. Good afternoon, everyone. I'm Shambhavi S. Uppin from KLE Technological University, Hubballi, and I am here to present the paper titled Framework for a Green Campus, LoRa-based low-power smart water management for campus, wherein our college is considered as a test bed. And the co-authors for this paper are Saroja V. Siddhamal, Vinod Talikoti, Preetam Umrani, Vinuta Kulkarni, and Sushma Hiremat. Coming to today's agenda, I would be speaking about motivation behind this development, methodology on how it is being implemented, the results, lastly conclusion, and the references. Now, coming to the motivation behind this development. As most of us present here know that water, which was once abundantly available, is now a more valuable commodity. On an average, about 1 billion people do not have access to safe drinking water. It is because we do not use water judiciously. Presently, there is manual distribution of water in campus, and due to improper management, it is leading to wastage of water, which in turn causes shortage of water in critical conditions. Manual distribution is in turn human dependent. Say, suppose we consider a college campus which has numerous departments and n number of overhead tanks. One person cannot monitor all these tanks at single instant of time. So there are many possibilities of ending up with improper management. And for all these unwanted situations, the reason is lack of standardization in monitoring and control equipment. So we present the design and development of a LoRa-based low power smart water management system in order to automate the water distribution in the campus. Now, let's come to the implementation details and different scenarios. So here, as we can see in the system, there is a main valve, which in turn is connected to multiple secondary valves and hence ensures the supply of water from main tank to different clusters. In order to automate the flow of water, a solenoid valve is connected in parallel to each of the secondary valves. The solenoid valve will receive the signal from the gateway to turn the valve on and off. The data collected from the sensor node is processed in the cloud, and the gateway receives the processed data from the cloud. The flow of sensor data starts from the sensor node to the cloud via gateway, and the control signal will flow from the cloud to actuator via gateway. The cloud can also send a notification to the user in an emergency situation. So till now, this is just an overview of implemented system in one building. So now let's see the complete architecture of the campus. As we can see here, the overhead tank or the main tank is having only one valve connection, which is the primary valve. And V2, V3, V4 are the clusters which handles two buildings each. And here the valves V5 to V10 are the tertiary valves which are connected to each of the buildings as shown in this figure. The solenoid valves are connected in parallel to the tertiary valves. Now let's assume an example wherein gateway is placed on the C-light building, and this the other departments like architecture, ENC, automobile, etc. are all sending the sensor data to the gateway which communicates with the cloud. So this is a complete campus architecture, and the key elements here are sensor node, gateway, cloud, actuator. So let's see one by one. Sensor node. Sensor node which act as end nodes are placed on the overhead tank of cluster of each departments. These nodes wake up every 10 minutes, collects the data from sensors and transmit it to the gateway. Due to this periodic wake up, low power is achieved. The power consumption of this node is 35 microamperes in sleep and 19 milliamperes in awake mode. So a 2000 mAh battery can survive up to 1.5 years with 50% discharge safety. An industrial grade waterproof ultrasonic sensor GSN SR04T measures the distance of water from the tank top. A LoRa RFM98W transceiver module is used to transmit the data to the gateway at 433 MHz frequency at the data rate of 300 kbps. The second element, as we can see here, is the gateway. Gateway is also having the same transceiver module to collect the data from all the sensor nodes, and the data collected at the gateway is sent to the cloud and stored over there. Thus, the actuation and deactivation signal to the actuator is sent from the gateway. The stored data in the cloud is used for further processing. Processing here means converting the distance data into water quantity in liters and checking it for the trigger percentage and critical percentage values. After processing, the decision is made and that is sent back to the gateway. The decision here is nothing but the actuation and deactivation signal. As I mentioned earlier, the cloud will also send a notification to the user. Now, here we can see the actuator. The actuator here is nothing but the valve controller. It consists of same transceiver module for receiving the actuation or deactuation information from the gateway, and thus the solenoid valve to pass or block the water. The solenoid valve is an electric valve that operates on water pressure at 230 volts 50 hertz AC supply. Now, let's see the control flow for water distribution. As we can see in this figure, the first one is the combined sensor data of all the buildings is present in the cloud. It checks for the triggering percentage of each of these buildings and supplies the water to the requested building. Now, suppose say one building sensor gives critical value percentage. Then it stops the current water supply and directs it to that building. Now, suppose a scenario arises wherein more than one building sensors give critical percentage values. Then it checks for the priority of the building and provides the water supply. Now coming to the results. Here we can see the implementation visuals. The first figure shows the satellite view of the campus wherein different departments are highlighted. Here, the red dots, which represents the sensor nodes, are placed on overhead tank of each of the departments. The green color are the valve controllers. There is one valve controller per department. And finally, there is a centralized gateway which is highlighted in yellow color. On the right top, we can see the implementation of the sensor node. This red color module is the sensor node. And on the right bottom, we can see the gateway. Next, this is the dashboard. This is a dashboard which is being designed wherein we can visualize the data on hourly, weekly, monthly, and yearly basis. And the data for individual tanks, that is individual sensor nodes, and for each department can also be visualized from this dashboard. This is the data visualization for one sensor node, that is one tank, for approximately a week. That is, the x-axis represents the dates and y-axis represents the water, usage of water in liters. As we can see here, on 19th of August, the water utilization is approximately 79%. Then on 20th, it is approximately 80%. So in an average for a week, the overall consumption for that particular tank is 80 liters. And we can see here on 25th of August, the water utilization is minimal as it was Sunday. Now, there is a comparison between the campus water management system with one of the existing solution, that is RanaKit. This is compared across various parameters. That is, first is the battery life. The battery life is approximately 1.5 years for CWMS and it is less than 72 hours for the RanaKit. Then battery health indication is there in CWMS and there is no indication in RanaKit. And CWMS works at a frequency of 433 megahertz while RanaKit works at 900 megahertz. And finally, the CWMS measures the water level while the RanaKit is used to measure various parameters such as pH, turbidity, dissolved oxygen, temperature, etc. Now, coming to the conclusion. A LoRa-based low-power sensor node and the gateway are designed to monitor the distribution of water, especially with low power. That is, 35 microamperes in sleep mode and 19 milliamperes in wake-up mode. Thus, this system also provides a user-friendly interface through the dashboard. Currently, the campus water management system is implemented in KLE campus to monitor the water usage and distribution. These are the references which are being referred. Thus, we come to the end of presentation.
Yeah, it is Sambhavi, right?
Yeah.
Yeah, Sambhavi, can you show me your results slide?
Could you please repeat? I couldn't hear.
Can you please show me your results slide?
Results slide, yeah. Here are the implementation visuals.
Yeah. In fact, the research is very good and apt for today's time. Yeah. I must say that. So, are you a research scholar?
I couldn't hear you, please.
Are you a research scholar? You're doing a PhD in this?
No.
Okay. Can you just tell me the amount of data that you have basically experimented upon or visualized?
For every 10 minutes, the sensor node is collecting the data. Like it wakes up and it transmits the data.
And so every 10 minutes the data is collected. So what is the rate of data visualization then?
Visualization can be based on the periodic, like we can choose.
I couldn't hear you.
Can
Can
you
you
just
please
go to
repeat
the
your
next
question?
one? Yeah, just go to the data visualization slide, the chart.
Okay, data visualization. Okay. Yeah.
So basically, what parameters are you comparing it upon? Have you first
Like we are going to measure.
taken a few samples where sensors were not put and then you are measuring it? How much water is being saved?
In the sense, I couldn't get you.
I just want to know that we are saying we are visualizing usage of water in liters.
Yeah, yeah.
So because we want to optimize the usage of water, isn't it?
Yeah, exactly. Because due to manual intervention, as we mentioned earlier, like there may be overflow. There may be one person who may be present in the campus, and he cannot look after all the departments. So there may be overflow of water, and due to which there is wastage of
Okay.
water. So we want to
So
automate it. Although by keeping the manual
are
walls,
sensors
yeah.
are sensors giving some notification to person about overflow or excess usage of water?
Your voice, I'm not able to hear properly actually. Could you please repeat? Sorry.
Uh, I'm saying this. I'm asking whether the sensors are giving notifications to the person where it is installed.
Yeah, sensors are not going to give, but there is a application through which the user gets the notification.
So he or
Sensors
she,
just wake up, collects the data and transmits. That is the work of
that is
sensor.
fine. Ultimately, it's the interface that gives the notification.
Yeah.
But I just wanted to know that the notifications are coming only about overflow, or the notifications are there about excess usage of water too.
Not exactly for excess usage of water, but it is for overflow and all.
Overflow. Maybe we can
Like
take
we
that
have,
as
like we have a specific, there are different tanks which are used in the college currently, and there are different water quantity which is hold in each of the tanks. So based on that, like what is the amount of water each tank can hold, we have the certain calculations for each of that. So based on that, we'll notify.
okay. But we can think of that as a future work. That maybe we can have a limit on the usage of water and we can give notifications about that also.
Oh, yeah.
In the next versions,
Yeah, sure.
in the next version.
In the next version,
Yeah, maybe we can work
taking
upon
your, we
that
would
also.
consider
That is
using
one
your
of
point.
one of the prospects that you can think about. Otherwise, it is a
Yeah.
very good project.
Yeah. We would be surely considering your point.
It's a very good research. I really like your topic.
Yeah. Thank you so much for your inputs.
Yeah, that's it.
Yeah.
That's it from my
Yeah.
side.
Thank you. Thank you so much.
Now we can call our next presenter, Om Lalchandani. Instead of Smita, he can present the paper.
Yeah, so this is Omlan Chadani. So I hope that I'm audible.
Yes,
Yes,
please
you are.
start the presentation.
Yeah, sure. Just give me a second. All right, so I have shared my screen. So I hope that the screen is visible to all of you.
Yes, it's visible. Please
Okay, well,
continue.
so good afternoon, everyone. So this paper is on robots and artificial intelligence as an aid to dependent people. So the co-authors for this paper is Professor Aarti Chandani, I myself, I represent a company and I work as a director of operations for Educard Education. And we have developed a robot prototype along with the help of Prakrit Prakash, who is a scholar at MIT. Besides, we have co-authors, Professor Smita, Professor Mita Mehta. So we got very valuable inputs from all of the professors. Right. So let's begin with the presentation on this. Okay. So as you all know that we are in the age of robotics and automation, and robots and machines. Robots are in fact the machines with tremendous potential. Um, these machines have ventured into various areas, various domains, like in the as a domestic help, for mobility, for guarding, for rescuing as an astronaut, as a help for industrial, and as well as in the social sectors of human life. Right. Then we are well aware now that there are humanoid kind of robots, where there are a lot of features which represent just like a human being, and they help us in a lot of things, like they can be helping in playing games, dance, and various interesting features. And then we have a category of robots which are called as androids, which demonstrate the training like human beings, and we are very well aware about the androids also. Then we have special robots, and we will concentrate more on the special robots, which are very useful and even able to cater to the special needs of people. And this is what it represents the topic also, that robots for dependent people. That was the focus for this presentation, as well as the research paper which we have done. And of course, we have a prototype ready, which can be used and for the special needs of people. So I'll now begin defining about what the special needs are, what would be the special needs, and how robots could really help in the special needs. So first, coming to the dependent people. So who are these dependent people? So these dependent people, really, they need some help. They might have developed some special health conditions, which makes them, which potentially they need some help from others. So for example, there are old people who have developed a health condition which makes them dependent on caretaker. And especially in the pandemic age of COVID-19. So as we all know that there are a lot of people who are unfortunately affected with COVID-19, and they need some support from healthcare workers. And this disease is such infectious, as we all know. If someone contracts this disease, so immediately quarantine in the hospital. And unfortunately, it's also a very great risk for the people, the caretaker, the healthcare people who are tending to the special needs of people who have contracted this pandemic. So if you have the robots ready for them to help, then it can save many lives of healthcare workers. So that's the reason that gave us an impetus to work on the prototype. And the dependent people, the subject is completely dependent on the day-to-day needs of the caretakers. In fact, the caretakers, um, they can provide help, but there's a problem. There's a problem that they can help in a limited support, and they have the risk of contracting the disease as well. So the scenario is already set to take the technology to the next level. And unfortunately, as we know, in the hospitals, not an extensive deployment of robots is available, as we all know. So we are again depending on humans or the human nurses, to tend to the people, and we cannot have a really close contact with the patients. And sometimes the patients suffer because due to there could be a number of reasons, right? And sometimes, there's a great risk to them. That is the stage is set for the robot, and I think this is the right time that one must really focus on developing the robots so that they can replace the nurses. Where in fact, not only for the COVID, but for so many other risky um, operations or the risky diseases which are very contagious in nature, and where the robot can actually help. And a lot of research is actually required, so that's the reason you see that artificial intelligence is very much necessary. The robots and artificial intelligence is necessary so that they can simulate the operations of a nurse, right? So a lot of research is currently going on, but there are a lot of gaps as well. Sometimes, the robots cannot really, simulate the work of a human nurse. And coming to the statistics, where we did, our professors really helped us in collecting the statistics. And the statistics reveal almost 20% of the worldwide population is perhaps living a stage where they are, in fact, heavily dependent on others. So there's a limited support due to a number of reasons. There could be limited support which a human being can actually provide. One is risk, and there could be a number of reasons why there could be a limited support, right? So if a robot is programmed to simulate nurse, so there won't be such limitations can be easily removed, right? And then coming to the literature, because I thought that maybe I'll discuss on what work was already done and what other writers or researchers have to say about this. And one is from Iladumot, from this particular reference, and the researcher has to say that there are many studies that there will not be enough resource in long-term care to provide assistance to
Sorry
everyone.
for interrupt, dear presenter. You have last 2 minutes. Please conclude your
Oh, I see.
presentation.
Really? Okay, so there were a lot of research was conducted, and the result from this research was that there are people who need this sort of help and assistance, and the people who need assistance, the dependent people is really growing, and one reason why it is growing that the life expectancy is increasing. It is because of the improvement in healthcare. So one is like the help which is needed in pandemics. And we cannot say that COVID-19 will be the last pandemic. There could be many other pandemics, and we have to be ready for that. And robots would be the essential help which can be provided. And then other type of people which would need this help is the old people. So nowadays, the concept of family, which we used to have currently, which is there in India, but in some of the Western countries, or also in countries like India, the people are really living in nuclear families and they're isolated. And sometimes, the old people, they have no one to tend to, and they need real help. So where, they're dependent on the nurses, and there could be various problems, right? So if we deploy a robot, which could be, of course, economical, that was another object, that robots should be economical in nature, so that people really can afford this robot, who could help them in their day-to-day work, right? And then this robot should not be a potential risk for a person like an old person, right? So there should be a lot of security operations. So if there is a potential danger from a robot, which is after all a machine, a snag or an error could be developed, so that the machine can be halted and rebooted. So that was an object, so that this robot could actually potentially help in the way that is required, and removing all the limitations which a person can actually provide with such limitations. So if a portable robot is deployed to help the dependent people, that is something which we are really looking into. So these were the various needs of robots, and AI is an area, artificial intelligence, which actually helps. A lot of nowadays, a lot of platforms are there where you can actually simulate the human beings operation with the use of artificial intelligence and various algorithms and programs which could be used in programming a robot. Robot is in fact a machine, so whatever you instruct a robot, it actually acts as per the instruction. And artificial intelligence means that that it develops its intelligence as it runs, as it moves, just like a human being. They develop the intelligence and we simulate this function so that this robot could actually simulate the nerves. And these some of the goals I already discussed, and these were the goals. Right.
Please conclude.
So basically, these were the goals, and the conclusion would be that we should develop such type of a robot which are potentially less risky in nature and economical. So that was the conclusion part, and a prototype is already developed with us, and we see that how we could bring it to the market for the help which is required to the people. That is all from my side here. And these were some references which I had taken. And this R is a language, R archives. There's a lot of programming, lot of programs are available which can simulate the artificial intelligence, and we can develop on that. A lot of basic programming is available, so we can use that codes and make it more and more intelligent in nature. So that is basically what I wanted to say. So thanks a lot for attending this, and if there are any questions, I'm happy to answer them.
Thank you, sir. Thanks for the presentation. I just have one question. What are the challenges while developing such robots?
Okay, so as I said that a lot of programs are available. So it means that we don't have to write the programming from the scratch. And because of the hardware, which is now readily available, like ARM of a robot, which is readily available. So we can purchase the ARM in a very economical rates, and then we have to program. So the challenges are that, first challenge is that it's after all a machine. So it should not potentially pose any risk to the old person or person who has contracted a pandemic. So if there is any chance that it is behaving in a very erratic manner, so there should be some operation so that it can switch it off. Immediately it could switch it off. So that was one challenge, and we have really worked on that so that it becomes lesser and less riskier in nature. And the other challenge is that how the nurse works, how the nurse works, and how could she take the temperature, for instance, if we are in the COVID situation. So how this nurse could take the temperature and what all treatment is given. So that we have to simulate using the machine. So the machine could actually use a syringe. That was a very big challenge, that how a machine could use a syringe to inject for the injection purposes. So that was very challenging. So the prototype is ready. So we are really working on this so that very workable, realistic in nature. And the other thing is economical. So it should be economical, well within the affordable range of, let's say, a country like India, where they have the resources and they could go ahead and purchase such a robot for domestic health or any other health. And then the hospitals who could afford these robots and swap them where the work of nurse is really very risky, and so that we can actually save so many lives. As you might have heard that so many health workers, even the doctors, did contract COVID, and some of them unfortunately also lost their lives.
Yeah, that is fine. That is fine. Right. Yeah, thank you very much.
Thank you, ma'am.
Now we can call our next presenter, Dipesh. Yes, ma'am.
Yeah. We can start off. Sorry.
Wait a minute. I am audible, madam?
Yes.
Yes, I will share my screen.
Yes, please.
Okay. Whether my screen is visible, madam? Hello?
Yes, sir, your visible. Yes, sir, your screen is visible.
Yeah, madam. Very good afternoon to the Anubha Jain, madam, session chair, as well as other dignity of ICTCS 2020. Myself, Dipesh Pardeshi. Today, I am presenting my paper on load flow analysis of 6 megawatt biomass power plant. This is my original work, which I have completed. This is the outline where I will going to discuss introduction, background, scope, then few diagrams, that is the block diagrams, as well as flow charts, research methodology, and I am going to compare results with actual meter readings, and then conclusions. So here, madam, this is the work. If statistics come from various quarters of the India and the world, then solar and the wind energy is going to become the promising one. But as we are going ahead from the ahead, then there is some limitation is going to get occur on such kind of technology. That's why there is one old technology is there which we are utilizing for the cooking of the food from so many ancient years, and that is the biomass. So there is called it as direct combustion of biomass. So same technology is going to get utilized for a generation of electricity. And here the concept is going to get put it, which is the basis on the load center. Load center means the center where you will require the energy. You will want to consume the energy. So by utilizing the resources which is available in that place, that is called a load center, we are going to get generate the electricity. And this is for these purposes, we are going to get use the agricultural waste. So because if you have seen the Delhi also, in Delhi there is a pollution is there, and that whole pollution is caused by the Haryana, Punjab and surrounding state farmers, because they are going to get burned the agriculture residue there, and because of which pollution issue is going to get created. Now this concept is already supported by the government also, and different government organizations like IREDA, National Corporation Developments has ready to financially support to develop such kind of projects. Then here this my study is going to get benefited to the country, as we are going to get reduces the transmission and distribution losses. At the same moment, it is going to get benefit to the society also, because in society there are a requirement of power is there, and that requirement of power is going to get satisfied by using the agro waste. So farmer will get the money for their residue, which is not none of the use at present. At the same moment, when we are going to get incorporate such kind of plants, then there is the employment is going to get created and pollution is going to get reduced. Then this study, whatever the study I have done, this study will provide the empirical evidences in improving the quality of electrical supply services by providing the electricity at the cheaper rate. Because at present in Delhi, you are see there is high rate is there, but in Maharashtra rate is very high. So this is our plant. This is the block diagram of plant where on which I have worked out. These are the machineries, because when we are going for any kind of any electrical analysis, then we have to go and search for each and every things. So I am going towards the generator, TG and generator set, which you can see here. I have to take all the details of it. I have to go for the transformer. I have to go for the supply, that is the feeding systems. I have to go for the electrical systems, and then the metering system. So whole system details we have to carry out. Then on the basis of this, I have developed the one system. In my system, I will want to run the load flow analysis. Load flow analysis is also known as the power flow analysis. And for that, what I will require? I will require to define the system topology and its connection. I have to define the utility connection, that is called a swing bus, which is used as a reference for running the load flow analysis. Then I have to calculate the individual loads which is connected inside this plant. Then I have to define each feeder and transformer sizes. Then I have to go and see the generator sizes also. Now, once I have studied all these things and collected the data from the actual plant, then I have to put this whole data, whole information inside this software. There are different softwares is available, which is called SKM, which is used by the USA peoples, and ETAP is also available. So I have utilized both the software and finding out the results. For that, in that software, there are some uh, actual available study laboratories also available. That is a cable library is available, transformer library is available, demand is there, direct connected load and studies. So these are the facilities which are going to get provided by that software. So I am taking the technical specification of standard. Suppose there is the LNT switchgear is there. Then that LNT switchgear, each and every detail is not necessary to enter by me. Only I will enter the details which are available on that plant, and remaining detailed technical specification I can take from this laboratory also. Then I have going to get run the load flow study, on which we are going to get say voltage drop is the more important concept which we are going to get utilized. Then we can say a power flow, how the power is going to get flow on each and every bus, and we are going to get study voltage angle and voltage drop. And then we can going to get our reports either in data blocks or either in printed form. Such kind of load flow studies are basically going to get utilized for the components or for the circuit loading condition. So in future also, or at present also, what is the condition? If the loading is going more, then there is a chances of the damage. Or again, if we want to increase the future expansions, then also this is going to get helpful. Then there is the bus voltage profiles we can going to get checked. So at which bus what voltage is there, so whether it is going to get satisfy the requirement or not. Then we can say real and reactive power study is there. So how much power you are going to get delivered to the customer, or how much power is going to get generated by your gensets, and that is going to get taken by each component inside the plant or outside the plant. Then we are going to get decided the power system losses. How much is the losses is going to get displaced? Because at present, what happened in Maharashtra, there is transmission and distribution losses lies between 38% to 40%. So huge losses is there. If I will generate 100 units, then 38, 40 units are going in west. That's why we are going to propose the concept that can design and develop the generating station at the load center where different sources are available. Now, this study is not going to get helpful only with this my point of view. Now, this side I have mentioned just so many another point is there, like the ideal power flow analysis, star protective devices, transient analysis, and so many which I have marked. So, with the help of same study, we can going to get two different kind of study also. So this is my single line diagram of the biomass power plant which I have created into the ETAP software. Then here it is not visible, so I am making some another changes. And this is my diagram. Here you can see there is a main generator is there, and through main generator everything is connected to the bus bar, and accordingly the line is going to the supply company from this side. So from this side we are satisfying the supply company load, and remaining all is my in plant load. So both load I have considered here, and for this I have chosen some criteria. My criteria is I have considered my branch voltage must be 3%, my bus voltage criteria must be 5%, utility impedances which is utilized by the transformer and motor generator sets, that is going to consider. Then transformer phase shift I have not considered, and for this I have utilized the one method that is called Newton-Raphson method. There are different methods of power flow calculation is also there. You can say Gauss-Seidel method is there, Newton-Raphson method is there, fast decouple methods are also there. So, and I have chosen I will require the solution that is exact. So here you will want to do the protective coordination study also. So apart from this, when I have done all the results, so the few results which I have mentioning is here I saw that there is a total loss in my system is going to get expressed. It is a 323 kilowatt. This is the active power which is in loss, and this is the reactive power 266 kVAR is the reactive power is required. So reactive power is definitely going to get hamper the power factor of your system. It is ideal that the power factor should be the unity, but it is not going to get unity. We are trying to reach towards the unity. If this power, reactive power is going to get increases, then it will going to get hamper my power factor. Now here I have checked the result, whatever I have got on each point. So here I have said the bus names is mentioned ACDB, DCDB, boiler oxys and cooling tower. Likewise, I have mentioned the different location of my plant, in which I have found out that there is for first ACDB and DCDB bus, there is only 2.06% voltage drop is going to get occur. Means a software is going to get detected, it is a 6.42 on that point, but actually it is going to get takes place, it is a 8.48. So here we have taken 5 is our reference, but we got here 8.48. Means here we have to take the actions and we have to reduce that voltage down below 5 volt. Likewise, here also you can say there is a cooling tower is there. At cooling tower, you can observe that there is actually 34.57% voltage drop is going to get expressed, and software has detected that there is 11.04% is there. So there is a 23.53% voltage drop improvement is possible. So we can save here the energy. So where it will going into the loss. Likewise, I have done the study for the whole plant, and at last I find out that the voltage drop taking place at various buses at cooling tower is 11.04, which we have to reduce. Main LV transfer, low voltage transfer, it is 6.42. ACDB, it is 6.42, and the voltage drop in cable from main LV bus to the cooling tower is 34.62. So this is the highest loss which is takes place, which we have to reduce. And the overall system is going to get finding out at 323 kilowatt. So even though this is not that much, but when we are running any kind of any system, our aim should be that the losses should be the minimum and efficiency should be the maximum. So from actual observation value found that the simulation or whatever simulation we are finding out is very close. and it is a satisfactory also. Load flow analysis form the basis of determination of both new equipment addition, means to reduce this, there are different kind of equipment is there that is called as a flexible AC transmission system. So we can going to get adopt the new technology also, and we can introduce the pack devices to improve the system. Then effectiveness of new alternative to present deficiencies. So here in cooling tower, we are finding out there is a deficiencies there. So we can add this equipment there also. Then we will want to, as population is continuously increasing, so we will want to go in that direction also. And if the load or energy requirement of that particular area is going to get increased, then by increasing the number of generators, we are in a position to increase satisfy that load demand. So here the reactive power losses is going to get takes place, and that I have mentioned is 266. So to reduce this reactive power losses, we can use a capacitor bank. Capacitor bank can use to compensate the voltage drop taking place due to several motors. Yes, there are three-phase induction motors are there which are implemented in that plant, and because of this three-phase induction motors, there is a loss is going to get takes place that is in inductive nature.
Dear
And whenever
presenter, you have last 1 minute.
yes, madam. So same line model I can utilize for the transient motor starting, industrial simulation, harmonics, and so many different studies also. So the future scope of my work is this work may be used as a future work conducted in the field of distribution generator and penetration of small agro waste based biomass power plant to the grid in creating the generation pool and opening a new source for people related agriculture to rise their lifestyle. This is my references which I have utilized this, and thank you, madam. Now I am open for the questions. Hello, I am audible, madam.
No, just I have no question. It is very good, and it's a very good topic, and you have thoroughly researched it. So I must congratulate you rather than asking you any question.
Thank you, madam. Madam, basically from last 3 to 4 years, I am working on this field, and basically in your Rajasthan also, I will want to work out on this project. There are few friends from the Rajasthan, that is in from College of Engineering, Udaipur. I have also consulted with them because in Rajasthan also, this issue is more burning of the agricultural residue. So once I have completed my work, then I am going to get propose this thing to College of Agriculture and Technology, Udaipur. Dr. Dave is there.
Right. Actually, it's very good, sir, and very much needed research of the hour.
Yeah, madam.
It's very good. All the best to you for doing your future work. Thank
Yes.
you very much.
Now we can call our next presenter, Polly Sen. Hello. Hello.
Ma'am, can you hear me?
Yes.
Just give me 1 minute. Good afternoon, everyone. Good afternoon to all dignitaries present, session chair, and I want to share my screen now. Am I allowed to do so?
Yes, please continue.
Thank you, ma'am. So, the name of my paper is Ontology for Preliminary Detection of COVID-19. The situation is not normal now. We all know that. We are stuck in a pandemic, and everyone is going through this. So pandemics specifically deals with health data. Health data comes in different formats like structured, semi-structured, unstructured data. Structure is like record-like structure, which means specifically demographic data. Semi-structured means sense data and XML-like data. And unstructured data means clinical notes, then images, videos, such things. So health data consists of these things. This type of data is preferably stored as big data because of the V features that we all know. And we prefer to use ontology for storing the health data as big data, because ontology is a knowledge repository which can be used to define a dynamic schema, and as and when required the ontology can be changed accordingly, the schema can change, and therefore data storage planning can change. We have proposed an ontology for primary care and basic child care before, and now we have to modify, I mean, during this pandemic we had to modify the ontology to incorporate screening and preliminary diagnosis in this new normal situation. Now we know what is COVID-19. It's a disease caused by coronavirus, a specific type of coronavirus called SARS-CoV-2, and who first found it out on 31st December, and it started in Wuhan. And these are the data available today on WHO's website, that these are the numbers of confirmed cases and confirmed deaths, and this is the number of countries suffering from this particular disease. Now, why we are using ontology, an ontology based technique can be used so that we are thinking about the initial situation of COVID-19, when it was slowly distributing, slowly spreading among the countrymen in our country or any other country. In that situation, this ontology could be used.
Hello. Hello.
Yes, Richa, you are audible.
I think Ollie have some network issue.
Yes, she got disconnected, I think.
Okay, so wait a few seconds. Otherwise, we can
Yeah.
move ahead.
Yeah, we can start with the next contestant otherwise.
Yes.
Yeah.
Yes, ma'am. There was some network problem. I'm very sorry for that. Can I
No
start
problem.
my presentation again?
Yeah, no problem, ma'am. You can start off.
Okay, okay. I have to share my screen again.
Dear presenter, we have very limited time, so please.
Yes, ma'am. I'm just trying to start it. I'm just having some problem here. Yes, I'll come to my own slide which I was using. So I have to move a bit first. So the options available now are Android-based options, mobile applications, then different IoT-based applications, remote diagnosis and advice. Now, what we have found out that non-contact mode is necessary and contact tracing is very important medically, and we have to use sensor, mobile, internet, and cloud. And kiosk-based application, if we are using, then it has certain phases like sensor data acquisition, symptom collection, history taking, knowledge-based query generation, and collection of patient's response. And whatever response they are giving, it has to be transmitted to cloud. Now, formal method to be followed for any IoT-enabled remote healthcare delivery means the normal, I mean, casually an application can be developed, but if one has all the entities and the relationship between the entities noted somewhere formally following some standard, then it is better. So we have specified the norm specified in WHO, and it focuses on history taking and the screening process. This is one example of an application, mobile application, where basic data can be entered and different symptoms can be noted. This slide. And in this field, the related work that I have studied is like this. So the first work represents different coronavirus diseases covering study of the virus and disease and gene-related study. The second one monitors COVID-19 and different associated respiratory conditions. The third one detects new cases of COVID-19 positives by using existing COVID-19 case database. The fourth one covers the case records of WHO, means the question answer related approach to assess something containing clinical signs, symptoms, these are considered. And the fifth one covers topics like prevention, diagnosis, treatment, cure, vaccine, so on, related to infectious disease ontology. Now, this is the workflow where, first of all, an entity is to be, it is to be checked whether an entity, a person, is a healthcare worker or not. If it is yes, then general symptom is considered whether fever is equal to 2, means fever is there or not, breathing problem is there or not. If it is yes, then sensors will be sensing vital signs. And if it is no, then if it is not a healthcare worker, then we check whether it is kiosk patient or not. Kiosk patient or not. Then the next case is general symptom is checked whether fever is there, breathing problem is there or not. So all the yes cases are considered. If all are yes here, I mean these different cases are yes, then sensors will be sensing vital signs. Now here the other cases are contact history is to be checked whether a person has come in contact of a COVID-19 patient or not. Travel history contains travel or not, and whether the person is a resident of a hotspot designated place or not. So in all such cases, yes cases, sensors will be sensing vital signs, and what we are finding here, body temperature is greater than 99 degree F or not, oxygen saturation is less than 99% or not, heart rate is greater than 120 beats or not, respiratory rate is greater than 24 breaths per minute or not. If such conditions are true, in that case, preliminary diagnosis concludes that suspected case of COVID-19, then the person has to be sent to a doctor for further advice and investigation. So this can be done by a kiosk or a mobile application. And if all answers are no, then no action needed as of now. So this is the workflow, and the ontology is made like this. Preliminary diagnosis is a type of diagnosis, which is a type of clinical information entity, which is a type of information entity. Then a suspected case is a medical condition, and others. I'm just considering the new entities that I have included for this particular case. Next one is that we following whose norms a person is typified into non-healthcare worker and healthcare worker, and there are different types of healthcare workers following whose norms. Then we know that ontology is used for understanding, interpreting a knowledge domain, and it is used for capturing, storing, and managing data accordingly. I mean, ontology is made on the basis of that data store can be made. Now we have health service provider in health sector and in other than I mean health sector. There can be other sectors also. For example, a college can also have a person who is a doctor who has been employed for some time. I mean, any organization can have such things. So such cases are considered here in this ontology. Then screening. What is screening? In normally population will be scanned for certain symptoms so that it will be checked by general test. It will be found out whether some attributes are present in them or not. So preliminary diagnosis, as I have told you, is a type of diagnosis which is a type of clinical information entity, and in ontology everything comes under thing, and this is a class specialization generalization concept only. And then we have vital signs which come under clinical science, and vital signs are considered in case of this particular work actually, and ontology detection. That's it. The types of medical history that we have used here are hotspot resident history, contact history, travel history.
Dear presenter,
Yes, ma'am.
your last 2 minutes, please conclude.
Okay, ma'am. So these are types of medical history, and then the types of sensors used. The all the sensors are defined here, but the needed sensors are used, as I have told you. And these are the object properties, means the different entities defined have some relation in between them. This association is particularly represented here. Um, that's it. And these are the list of references that I have used in my work, and I'm waiting for my questions. Thank you, everyone. Any question, sir, ma'am? Ma'am, I cannot hear you. I think you are muted, ma'am.
Yeah. Sorry. Yeah. Ma'am, it's a very good research. Again, people are doing a lot of research during COVID times and how to treat the patient. So can you just please tell me what are the future areas that you are going to cover in this?
Sir, sorry, ma'am. Ontology can be enhanced as and when required. In any pandemic, this can be used. Not necessarily these particular clinical signs or attributes will be used, but some other attributes can be used. And in such cases of pandemic, this ontology can be modified and can be used. Okay. And in general, the target is to cover primary care. We don't have any electronic health record standard used in our country, and the future is enormous actually in this field. Ma'am, you are again muted, ma'am.
Yeah, right. Okay, thank you very much.
Thank you, ma'am.
Now we can call our next presenter, so Venkatesh Rao.
Yes, ma'am.
Yes, please go ahead with your presentation.
Yeah. 1 second. Is it visible, ma'am?
Yes.
Yeah, ma'am. Good afternoon, everyone, ma'am. Myself, Venkateshwar Rao. Today I'm going to explain the topic which is energy efficient wireless sensor deployment for lifetime maximization by optimizing through improved particle swarm optimization. So this project I done in MTech major project. So coming to Coming to presentation outline, you have abstract introduction, problem definition, and literature survey, and then what are the requirements, and then like high level
You
design
can
and
open it in slideshow mode.
yes, ma'am.
And dear presenter, please make sure we have a limited time, so
Yeah, ma'am.
stick to the time.
Yeah, ma'am. So these are the presentation outline here: high level design, low level design, and then final results, and then conclusion references. So coming to abstract, as we know that in wireless sensor network, there is a most important thing is energy utilization when sensors are deployed in the network simulator. So for that, many researchers have developed many algorithms, routing algorithms to reduce the energy in the sensor networks. Many have successful, and then some are not successful for to minimize the energy in the wireless sensor network. So to elevate this problem, this paper I proposed the energy efficient clustering protocol, which is IPSO, like improved particle swarm optimization. So this can overcome the energy optimization in wireless sensor nodes, and it prolong the network lifetime. This paper we include the two more features, so which is nothing but um, to help the reduce energy consumption and throughput of the network model. So the two more features is known as, we propose the dual cluster mechanism, and we when the cluster head, if the cluster is right, automatically this deputed cluster head node is activated as a cluster head. Finally, the proposed protocol is compared with the existing leash protocol and then existing PSO protocol. So so as we know that usually the nodes powered by limited battery. So for every sensor, the most important thing is energy, which is power in terms of battery power. So the purpose of extending lifetime of can be achieved by reducing the energy consumption. So here come in the first phase, the sensors are deployed in the network simulator based on the energy and the momentum of the sensor nodes, like velocity. It will deployed in the sensor nodes deployed in the network simulator. After deployment of sensor nodes, the energy calculation will be done. No, distance calculation will be done from the each sensor node to sensor node. That is based on some mathematical formula of by choosing the x-axis and y-axis. It will calculate the distance for every sensor node. And then after the calculation of distance based on the distance, the clusters are formed in the network. So after the calculation of the sensor node distance, the sensors are like we deployed the 50 sensors in the network simulator, so that we want the clusters are formed, like 5 clusters are formed based on the distance between the sensor node and sensor node, and then energy of the sensor node. So in the second phase, we have to find the cluster head. So the main thing is we are using cluster head here is, so if individual sensor node sends the data to the base station, so it will utilize more energy for the sensor nodes. So here we developed the cluster head for each cluster. So for that, energy of each sensor node is calculated, and fitness of the each node is calculated. So here, based on fitness value of cluster is formed. After forming cluster, the data transmission will be done from the remaining nodes to cluster heads. Once the cluster head selected, then within the cluster head, the remaining nodes will send the data to that cluster head. Then that cluster head will send directly the data to the base station. And then we will implement a new feature, as I already said, deputed cluster head, which is nothing but one. If the cluster head will is die, unfortunately, then we propose this deputed cluster head. It will elect as like secondary cluster head, which can activate the cluster head. We also implemented the one more feature, like using MEMLE, maximum likelihood estimation concept, to recognize a malicious node, which is nothing but it creates some fake energy, and it will develop as a sensor node. So by using this concept, we can detect that malicious nodes. This is the then we can utilize the energy by detecting that the malicious nodes in the sensor. So this is main thing, domain wireless sensor networks. We know that it consists of base station and sensor nodes. It will send the data to the base station. So this is the base station. This is base station is the destination for the source of the sensor nodes, which act as a gateway between the sensor nodes and the internet user. Once the base station receives the information, it will gives to the end user. This is the main concept we use in the paper. Particles. This is particles form optimization.
Dear presenter, you have last 2 minutes.
Yes, yes, sir. Particle swarm optimization is it will provide the candidate best solution by iterating the particles. Here we take the concept of particle swarm optimization from the flock of bots, which is trying to find some best solution like food. Then from that example, we define the particle swarm optimization in the existing paper. We implemented this particle swarm optimization. So module for the proposed algorithm. Here network deployment, cluster formation, and cluster head selection. And then after selection of cluster head, the data collection and tree formation will be done. And then that collection data is transmitted to base station. So this is the data flow diagram. Yeah. So this is the network deployment. As I said that initially the sensor nodes are deployed in the network simulator based on the velocity and the energy of the sensor node. It will be deployed in the network simulator. Here, after the forming of the sensor node, the cluster formation will be done. This cluster formation will be based on the calculated distance between the sensor nodes and then related sensor nodes, and then energy of the sensor node. The cluster formation will be done. So this is the main thing we use it in this paper. This is cluster head selection. In this portion, that improved particles form optimization algorithm will be used. So during this phase, this signal is provided since once the nearby nodes are identified, nodes within the range, select those cluster numbers. So
So can
cluster
you
head
come on your conclusion slide?
yes, yes, ma'am. Yes. So this is the main problem definition. No? This is the requirement analysis, high level design. Performance analysis. This is the graphs, energy consumption, throughput, and packet delivery ratio. This is the graph structure. So this is my conclusion. This paper proposes improved particles form optimization. So here we use this particles form optimization to select the best solution. This particles form optimization can be give the best solution by taking some inputs, and iteratively it will done steps, and it will give the best solution to elect the cluster rate. So these final experiment results show that only this proposed algorithm has high accuracy, but also in conversion rate significantly improved. In the future, we'll consider how to apply node localization in wireless sensor networks. Yes, ma'am. This is the, my some references I have to. Yeah, ma'am.
Okay, sir. I have this question for you.
Yes.
That what is the termination criteria for your PSO?
Termination criteria.
Yeah. Basically, how many, because you're saying your convergence rate is high of PSO, what changes have you done in PSO?
Yes, ma'am.
Changed its parameters?
Yeah, ma'am. So in the existing cluster rate selection, they use only one cluster rate. If that cluster rate, I mean, there is no depute cluster rate. So here we proposed the another cluster rate, deputed cluster rate, which will take some another input like distance between the base station to sensor nodes. We taking that parameter and we'll develop this deputed cluster rate, and also we developed that MLE concept to detect the malicious nodes. This is the improved things in this paper.
Okay, thank you, sir.
Yeah, thank you, ma'am.
Now we can
May-
call our next presenter, Neerav Patel.
Good afternoon, all. Am I audible?
Yes, Neerav, please continue your presentation and make sure we
Okay.
have a limited time. So please, as soon as
Okay,
possible,
sure,
you
ma'am.
conclude your
Sure, ma'am.
presentation.
Now I'll share my 1 minute. One. Okay, my presentation is visible. I
Yes,
guess.
it is. Yes, it is
Okay.
visible.
Okay. So as you know, I am Neerav Patel, a research scholar from Parul University, and my today's topic is the behavioral changes in strength of the concrete when normal reinforced concrete when we include the waste plastic fiber. So this is my presentation agenda, and I will discuss it into in presentation continuation. So I'll skip it. Now, what is the why I choose this topic? First of all, so for the construction purpose, we have an environmental constraint. We have two biggest issues in coming years, and it is also there right now. First one, for the if I talk about the construction purpose, uh, all the construction were made up were or will be going to made uh, by the all natural materials such as cement. Cement is also natural material. Sand, we are used conventional sand by digging our river or any water bed of the water. So and again the coarse aggregate is the same thing. It is all the natural materials. Then water, we require water for the making of the concrete. So these four are the main ingredients actually. So, and these all four are the natural resources, and we are now in the stage of that we are doing the construction in a very haphazard manner. I must say that we don't know, we don't take it the environment into the consideration in this case. Similarly, the second one is the biggest problem for the world is and the environmental perspective is our the plastic uses, day-to-day plastic uses, and we simply throw it out our day-to-day plastic uses such as polythene, carry bags, water bottle. There are a lot of other plastic materials are there, but if I'm talking about our main regular uses for regular day-to-day life, we will throw it. And that material, yes, plastic is recyclable material, but that material again, the collection is a problem, and the second one is to recycle it is very costly to make costlier than to create the new one. So people are creating the new one instead of recycling it. And again, I am talking about our day-to-day plastic uses. So these are some plastic waste analysis are there. So for day-to-day, why plastic is very much useful and all the things. So we know it is a low density, lightweight, good strength. It has ability to carry a liquid things, and it's made up of very cheap cost. Now, plastic products worldwide, it is 2019's data, 359 million tons, and Europe and China individually use 60 million tons each. After that, USA consumption, then Brazil, and India is uh, the fourth one by producing the day-to-day plastic waste. Uh, the right hand side figure shows the indicates that grade 1 figure is the average plastic consumed, and the percentage black one in bracket, that percentage values are indicate that this much only amount we are going to we are able to recycle that plastic waste. So only 6.92 means around 7% of our day-to-day uses plastic materials are going for the recycle purpose. Other than other 93% will going for the landfill or waste in sea, river. So this 93% waste plastic is very much create environmental issues. Now, this is also some India's waste plastic problem. Then, if we say I'm starting with the left hand side figure, that waste, sorry, the way we have used 9,000 Asian elephants. That is that much amount of weight we are producing yearly. Then, sorry, every day. Then, what is the plastic? So it will take 400 years to take a decomposite of single plastic bottle, our water bottle, even smallest one. So these are some values: 6.3 billion ton plastic waste that had accumulated globally, 12 billion tons likely amount to go for the landfill by 2015. So these are the data is available, and again it create more problems in day-to-day life and environmental issues also.
Neerav, can you please speeden up a little? We are
Okay.
running out of time.
Okay, no problem. So plastic waste, I'm skipping it. So plastic is, all aware of about the environment, what is
Please
its
come
cause and what is the.
directly to your research work.
Okay,
Skip the
so
introduction.
okay, again, this one is the concrete data. What is the concrete consumption? I already explained this. Is again the natural portion, natural materials consumption. So now we require some new materials to give the better strength of the concrete, and again to reduce the natural materials. So these are some today currently these some materials are going to use for the some innovative things apart from the natural things, man-made materials. So these are the manufactured sand, fibers, and high ash concrete, fly ash bricks. But again, this we need to make in factory. So we require some of them are made up of again natural things. But what I am going to do is I am combining these two problems in for the solution purpose. I want uh, to plastic waste as a fiber material, and I want to include it. I'm already included it in our concrete as a concrete material. Then what will happen? So now the part is that when we include a plastic waste as a material inside the concrete, then there is a two option. One is the aggregate and one as a fiber material. Aggregate, again, the two types of aggregate, fine and coarse, and fibers we have two types of day-to-day plastic wastes are there. PET means polyethylene terephthalate, which is uh, which is used in our water bottle, soda bottle, that thing. And MWP, metallized plastic waste, is used as a small or weaker polythene. So two types of fibers are there. Then aggregate, if we include aggregate as an aggregate, then the percentage of the
Dear presenter,
aggregate
you have
the
last
aggregate
2
by its
minutes.
volume is 10 to okay 10
Please
to
conclude
25
your
minutes.
presentation.
So okay, now for that, in my presentation, I have included plastic waste as a fiber, and these are the some concrete mixes are there. The cement I was at 53 53 grade cement, which has specific gravity. All mentions are here. Now, plastic waste I have uses three types of plastic, three lengths different: 10, 15, and 20 mm. Width has a 2 mm. So these are the data which are which were I have used. So again, this is the specimen which how many numbers of specimen or which type of specimen I use for this practical. Now, for the result purpose, as the result indicates, first one is the concrete volume to its density ratio, and the density as I am increase my plastic, as a plastic is a very lighter material, it will decrease the concrete volume, sorry, density and weight of the concrete, so our structure become lightweight. Then second is when slump test means workability, so flow of the concrete as uh, percentage of plastic waste include, the flow of the concrete will get reduced due to not proper mix up in the concrete. Now the strength part, if I include the plastic waste is a fiber material, the strength will go increasing, the compressive strength will increase by the will increase at the 1% of inclusion. Similarly, the tensile strength and the flexural strength will increase at the inclusion of 1.5% of doses of the plastic waste fiber by the concrete volume. So, and again, it's depend
Sir,
on the
come
length
to
of
your
the plastic
conclusion
fiber.
slide. Can you please come to your conclusion slide now? Yeah.
Yes, ma'am. This is the summary. So, as I said, mentioned in the graphical represent that workability of concrete mix is decreased due to the
So
not proper.
I just have one question, sir.
Okay,
While
ma'am.
mixing these different fibers, are
Yes.
you working in some factory or
No,
some
no, ma'am.
industry area? Where do you mix them? In the lab?
The lab, ma'am.
So then that would be a very small proportion of mixing, isn't it?
Yes, ma'am. It's only our day-to-day concrete cubes and flexure cube only.
So
So this result
what temperature is being used while mixing all these things?
room temperature, ma'am.
Okay, in the room temperature itself, it gets mixed?
Yes, ma'am.
Okay, thank you, sir.
Concrete is also.
Richa, can we take the last one? I'm running short of time, actually.
Yes, ma'am.
Okay, ma'am.
Now I would like to invite our last presenter, Dipesh Vanwani.
Hello. Am I audible? Hello.
Yes, sir, you are.
Thank you.
You can start off and please skip the introduction and come to your own work part.
Yes, ma'am. Yes. Is my screen coming? Please let me know. Hello.
You are audible, you can start off.
Yes, my screen is coming, right?
It's visible.
Okay, thank you. So my topic is bio-inspired algorithm for minimum spanning tree for cognitive radio network. So in this work, I am proposing to construct degree constrained minimum spanning tree. So what is the degree constrained minimum spanning tree is where each node has been restricted to have a maximum degree of D. So as the real life example, we can see when we construct transportation roads means, so we first create a network and we decide how many roads are going to meet at a certain points. So there we constraint the degree of each node. So that is what I am going to do in cognitive radio networks. And minimum spanning tree has so many applications like in optimization and all. So for this purpose, I have used bio-inspired algorithms. Two of the bio-inspired algorithms I have used. First, this is my system model. where I have used means every node will have distinct ID, every age will have distinct weight. I am going to use genetic algorithm for pheromone distribution, and then I will use ant colony optimization to construct those spanning trees. Then yes, let's go move on directly to the proposed algorithm. So this is my proposed algorithm. I am going to illustrate it with an example. So first I am using genetic algorithm. For genetic algorithm, all the parameters which used to construct uh, this gene, as we can say, they all are uh, described in the formula earlier. So for these things, I will perform one point crossover, as we know in genetic algorithm. Then I will do bit flip mutation to avoid that minimum optimization. And then I will use, and then as the genetic algorithm progresses, it iterates over and over until we get a satisfied solution from it. Then let's suppose that this is the satisfied solution, or this is the solution I'm satisfied with. Then the cost, it will be calculated by the, if this is the 9 bits number, so I will convert it into the decimal number, and then I will deduct it from the maximum value, which will be the 468, and that will be the pheromone value which will be distributed. Then I will use ant colony optimization for constructing the network using the pheromone, uh, because all the pheromones are already there. So I will use ant colony optimization. So I started from node 0. So before we go ahead, let me tell you why did I use these two algorithms. So first, in in, in Sol ant colony optimization algorithm, we generally use broadcasting for pheromone distribution, which is very highly and very expensive operation, which results in very high complexity. So for that purpose, I have used the genetic algorithm. For construction, if we use genetic algorithm, as we know, has very high computation complexity, but also very poor, while the dynamic changes are being made to the network. For those purposes, time colony optimization is very good, because in and colony optimization, the construction or the tracing of the path is very simple, and also it is very rigid to dynamic changes to the network. So to continue my example, now I have started from this node 0, and I am sending all the ends from to all its neighbors. So like, and the minimum cost of edges will be covered first. So as you can see, all the edges are covered first, and if it reaches to 4, but our 4 have as 7, as 5, has 8, so all of them have greater rate of edges. So first all of these will be covered, and if we continue this, we will get a spanning tree. It is not a minimum spanning tree, it is just a spanning tree. Now if we notice it carefully, like in this example, so it is a spanning tree, and we will get a total weight of 41. If it was not, if there was not the condition of degree constraint, it would have been minimum spanning tree. But instead, but because of the degree constraint, we cannot use the 0.5 age here, which had the weight 2, because it will, because maximum degree in this example is 3, so it will violate that property. So it is not a minimum spanning tree, it is a spanning tree. Now to convert it into a minimum spanning tree, I will be using one edge replacement method. One edge replacement method is mentioned here. It will try to replace every edge with the edge which is not present in this network, and try to compute that total weight. And if the total weight is less than the our weight already mentioned, then the edge will be replaced, and this process will go again and again in iterative manner. So this is the one edge replacement method. And so as we can see, this was the spanning tree. Here we are doing interchanges, swappings. So first we have swapped that age 08 with 05, and then as we can see, 08 with 05 is replaced, and then 04 with 08 and 5 and 6. So after three swaps, I will get this resultant minimum spanning tree, which have the which has the cost of 39, which is all real less than the spanning tree cost which we computed initially. So it is less than the, so it is our minimum spanning tree. This algorithm is yes, this I will conclude. This used two very common bio-inspired algorithms, and as I mentioned, Jaleki algorithm senses the network and pheromone distribution, and then colony optimization is used to construct a tree. For this, we have assumed some, we have made some assumptions like there will be, if PU means primary users comes, the process will restart again, and yes. Yeah, that's all from my side actually.
Yeah, thank you very much. Thank you very much, Dipesh. I have only one question.
Yes,
How
sure.
many runs of genetic algorithm are you taking for your experimentation?
Yeah, ma'am. So I have made choices between two conditions. Either if the runs are 10 to the power 5, or we
Okay.
get the desired result before that. So if we get desired result before that, and desired result means the probability should be, means we can mention this much probability we need or this much cost we need. If we get better cost than that, we will stop the process before those.
Okay. Thank you very much, Dipesh. Thank you.
Thank you, ma'am.
Thank you so much. I sincerely thank our researcher for their excellent presentation in this technical session. And thank you to all participants for being a part of this international conference. I hope this session was very informative and knowledgeable. All the presenter would be getting their digital certificate, payment receipt, thank you letter through mail within 1 working day. Further, all the papers have already forwarded to the Springer for a publication process. The publication will be live within 4 to 5 months. Kindly cooperate with the team of ICTCS 2020. Now, I sincerely would like to give a warm regards to our session chair, Dr. Anubha Jain, for chairing this session. Thank you so much, ma'am, for your valuable time and presence. This is a sweet greetings from us.
Thank you, Richa. Thank you very much. And thank you once again to Amit Joshi sir and Mihir sir. Thank you to all the organization committee. Thank you very much.
And I just want to kindly request to everyone to turn on their cameras for this quick snapshot for the sweet memory. Done. Thank you so much. Ma'am, this is your certificate. This is a greeting from us.
Thank you, Richa. Thank you very much.
Thank you so much, ma'am. Thank you so much, all presenters.
Bye-bye.